Have you ever seen an artificial intelligence model make a prediction that just felt completely off, even after extensive training? It is frustrating when a model acts unpredictably or gives unreliable results, undermining trust in its capabilities. Data consistency is absolutely crucial for model training because it directly impacts the model's ability to learn accurate and generalizable patterns from the data. Without consistency, models struggle to identify meaningful relationships and perform poorly in real-world applications. The core mechanism is simple. Machine learning algorithms, particularly deep learning models, thrive on clear, stable patterns. Inconsistent data introduces noise and ambiguity, making it incredibly difficult for the model to distinguish between true signals and random variations. Imagine trying to learn a language where the same word is spelled differently every time it appears, or where sentence structures constantly change without reason. The model might interpret variations in feature scaling, different units of measurement, or inconsistent categorical encodings as significant features when they are merely artifacts of poor data preparation. This leads to models learning spurious correlations instead of robust underlying principles. For example, if some images in a dataset are high resolution and others are low resolution without proper normalization, the model might associate resolution with class instead of actual object features. Similarly, missing values handled inconsistently across a dataset can create entirely new, incorrect patterns for the model to learn. To ensure consistency, focus on a few key practices during data preprocessing. Standardize numerical features so they have a consistent scale and distribution. Carefully handle missing values using consistent imputation strategies, such as mean, median, or a specific constant. Ensure categorical features are encoded uniformly, perhaps using one-hot encoding or label encoding consistently across all data. Regularly validate your data against a predefined schema or set of rules to catch inconsistencies early. Consistency checks are not a one-time task but an ongoing process. This diligence helps prevent issues like data drift, where the statistical properties of the target variable or the relationship between input features and the target variable change over time. When input data changes in unexpected ways after deployment, a model trained on inconsistent data is particularly vulnerable to performance degradation, struggling to adapt. An often overlooked aspect is temporal consistency in time series data, where the sequence and timing of observations are paramount. Maintaining this consistency ensures the model truly understands temporal dependencies. By prioritizing data consistency throughout the entire machine learning pipeline, from collection to preprocessing, you empower your models to build robust internal representations of the world. This disciplined approach translates directly into more accurate predictions, greater model reliability, and ultimately, more trustworthy artificial intelligence systems that deliver real value.